Good day, future engineers. Today, let's discuss about moment of a force. Our lecture will include the concepts of moment, couple, and properties of couple. Then we will apply those concepts to transfer a force from one point to another using force-couple system. We will also utilize the Varignon's theorem to simplify moment analysis. And lastly, we will see how to reduce a given system of forces into a single force. Take note that when we say system of forces, it does not mean forces only, but also moments. First, let's define what is moment. Moment of a force, torque, or simply moment is defined as the tendency to rotate with respect to any point due to applied forces. Take note of the word tendency. That means the object is about to rotate if not resisted by any counter moment or force. To visualize, consider this wrench with force F applied near the right end. In this animation, it shows that the wrench has a tendency to rotate with respect to the bolt, or let's say point O, which creates a clockwise moment about point O, or denoted as M sub O. When we have the value of length L and magnitude of force F, we can compute for moment using this formula. Moment about point O is equal to magnitude of force F times length L. For this example, point O represents the moment center, while length L represents the moment arm. Also, it can be noticed that force F and length L are perpendicular to each other. Therefore, when using the formula, make sure that the force and moment arm are oriented 90 degrees with each other. Since moment is equal to force times length, its unit is commonly expressed as Newton meter or kilonewton meter in SI, and pound inch, kip inch, or kip foot in US or English units. Recall that 1 kip is equal to 1,000 pounds. Now, to establish our sign convention for moment, let's make use of the right hand rule, in where the curl of your fingers, except your thumb, determines the positive direction for moment. In this figure, the direction of that curl of fingers is emphasized by this blue curved arrow of moment. By isolating the top view, we can see that the direction given by the right hand rule is counterclockwise. Therefore, we will set all counterclockwise moment as positive and clockwise as negative. Regarding the right hand rule, we will emphasize more about this in our future topics when we deal with 3D rigid bodies. But for now, let's focus on 2D. Please take note that for 2D problems, moment of a force is taken about a point instead of an axis. A special case that you must remember when dealing with moments is when the line of action of the applied force intersects the moment center. When that happens, that force has zero moment arm, which means it cannot contribute any moment about the given point. To gain some physical sense about the moment formula, consider this animation. You can notice here that torque or moment can be increased by either increasing the applied force or the length of the moment arm. So when you want to rotate an object about a point, you may consider utilizing longer moment arm in order to lessen the force that you should apply. But not all problems consist of moment due to a single force. In fact, different forces can produce moments with different magnitude and direction about the same point. Thus, it will be easier to deal with those problems by reducing all those tendency of rotation into a resultant moment. So with respect to this figure, we can get the resultant moment about point O by just getting the summation of all moments about point O. Taking note that counterclockwise rotation is set as positive. For this example, that summation is simply equal to m sub 1 plus negative m sub 2, negative since m sub 2 can create clockwise rotation, and then plus m sub 3. By expressing each moment into the product of their corresponding force and moment r, we can express the total moment about point O in this equation, or into this equation. Let's apply now those concepts in sample problems. For our first problem, we are given this figure and we are required to solve the moment about point O and find the vertical force that can replace the given 500 Newton force to create the same moment about point O. All these requirements can be represented by these variables. First, let us solve for m sub O. Since the given force is inclined, it will be convenient to resolve this force into its components so that we can make use of the given 1 meter and 2 meters as their corresponding moment arms, which are also already perpendicular with the force components. Before resolution, we solve first for this angle theta, which can be expressed as arctangent of 3/4 equal to 36.87 degrees. Next, by resolving the 500 Newton force, we get F sub x is equal to 400 newtons, while F sub y is just equal to 300 newtons. Because we're aiming for the value of moment, we will just use absolute values of forces and consider later the proper signs when we substitute these values to the moment equation. Now that we have these force components, we can express moment at point O equal to the summation of moments due to the force components, which is just equivalent to the sum of the products of the forces and their corresponding moment arm. Finally, by substitution, we get that total m sub O is equal to 400 newtons times 1 meter plus negative 300 newtons times 2 meters. Again, the negative sign is due to the clockwise rotation that the 300 Newton force can create about point O. Adding these values, we get negative 200 Newton meter, or that the total moment about point O is equal to 200 Newton meter clockwise rotation. In the given figure, we can draw that moment as follows. Next, let's solve for F sub v. We are required to retain the obtained moment at point O, but this time, that moment will be due to force F sub v. By investigation, we can conclude that this force must be directed upward in order to produce a clockwise moment at point O. So our solution will start by summing up all the moments at point O, which is just equal to the moment due to the vertical force only. And then by substitution, we now have this equation with two variables. Recall that The value of m sub o was already obtained previously. Therefore, we can write that m sub o is equal to negative 200 and also equal to negative f sub b times 2, giving us a positive value which is positive 100 newtons, or F sub B is equal to 100 newtons upward. Take note that if you get a negative value of the force for this kind of question, that only means that you use a wrong assumption of its direction. So for our next problem, kindly refer to the next part of this lecture. So that's it for now. Thank you, class, and God bless.